The project is the gas pump. So to do the gas pump, it's using the button to enter the money. So you go into a gas station, you pump in how much money you want to buy the gas. And after you finish it, then the gas will start to pumping it. After the gas is finished, then you will say thank you and come again. So the loop goes round and round. And so we're using the button to simulate the internal money. And then we use the lights to indicate the status of the pump. So when the green light is on, that means the pump is ready. So when you go in, the green light is on. That's it, the initial state. The green is ready to take your money. And you can start the enter the money. If you want to enter $7, then you pump it 7 times. If you want to enter $53, then you pump 5. Then you wait a little while and then pump the 3. Yeah. So somehow you have to be able to figure out that what is the 5 or what is the 3 and versus 53. And so there are some timeouts you have to design it in and use your common sense to say that what would be the right number. Okay? And to start with, I think you should just using the single digit. Let's say we will do only single digit dollar. Say $5, you pump 5 times. $3, pump 3 times. Push 3 times. Okay, so that's the green. And every time you hit a button, I think that the machine should give you some feedback. It says ding, just like a blink of the green. That means I got it, I got it. Okay. So when you finish it up, then the pump will start delivering the gas. And the more money you put in, it should pump longer. And when it's delivering the gas, we can use the red LED to flashing it, and so whatever the speed you want to flashing it, they should corresponding to how much money. The length will be corresponding to how much money you put in. And later on, if you have more fancier stuff, you could actually just speed up the flashing if you pump in a lot of money, so you don't have to wait a long time. After the gas is done, you will have flashing the 3 times, like say thank you, and then having both red and green flashing 3 times, and then go back to the green again. Okay, so this is the set of the requirement, and let's look at what would be a state diagram. So this is one implementation that I have, and obviously it cannot be the only implementation. Everyone can have a different way of doing it. But one implementation I have is I just go ahead using the state diagrams. And the state goes like this. Everything starts with the idle. And when it's idle, the green light is on. And once we got an idle state, it's user coming in to push the key. Once the key gets pushed, the first key gets pushed, you will get into another state of the machine. The state of the pump will be in the get money state and eat your money. So in this state, if you continue to hit the key, you will continue to stay in here. And then every time you hit the key, the green will blink to acknowledge the key hit. And if you after a long while, you didn't hit any additional key, that means you are done with the money part, input money part. That's where the timeout comes in. The timeout comes in, then you got go from transition from get money state into the pump gas state. So inside the pump gas state, that the red were flashing during the gas delivery. So this is where we say that the more money, you're going to stay in this state longer. Okay. And once it's done, it's finished, you pump all the gases and then go back to a thank you state. Within the thank you state, you are flashing red and green 3 times. After you flushing it, you go back to idle. So it's a simple 4-state transitions. So what makes the state transition? There are 2 things make the state transition. The one thing is the key is making the transitions, especially the first keys. The second keys and the third keys, they all stay within the get money state. Okay? And then the other one is that the timeout will get the transitions from the get finish up entering the money, going to the pump gas. So what's the event causing these guys pump gas to go into the thank you? In fact, there isn't really an event triggered by us. It's really the computers automatically will transition from pump gas to thank you whenever he finished the pump gas. And the same thing holds true is that after the thank you, he automatically transition to idle without any user interactions. So this is the 4-state transition table. Okay, so let's look at how this is going to get implemented. This is the main program, and I think by far you should be quite familiar with it. This is the main program part. Okay? The main program part here, it's wrong one, don't move it. Okay? The main program here, stopwatch dog timer, and set LEDs, and turn off LEDs, and the next few lines is enabling the button, and I think those are the things that we have exercised on previous day. All right, and then we turn on the timers. So the timer is a 500 milliseconds continuous running timer. So this is where we can use to measure that are we going to get a timeout after we finish the money or not. Okay, and the important part to understand is these 3 things here. We create 3 variables to store to make this machine running. The first one is the state, and the state is an integer. We're just using it for 0, 1, 2, and 3. Okay? And then we have a key count to count how many keys we hit. That means we count the money, how much money we put in. And then we have a tick count. The reason for the tick count is that our timer is only 500 milliseconds. So every time 500 milliseconds expire, we just increment a tick. This is really just to help us for, suppose we're using 4 seconds for the interdigit timeout. That means that after we enter the money, that if we don't continue to enter it within 4 seconds, then we say we finish the money. Okay, and so we create the 3 variables as global, so that both the main program and interrupt service routines. How many interrupt service routines we have? Because we're using the keys and we're using that the timers, we will have 2 interrupt service routines. And those 2 interrupt service routines, we'll go into it in a bit, just in a few minutes. But we have to create those 3 things global so that both the main program and the interrupt service routine can access to it. Okay, so this is really these 2 lines. The integer just blink green, blink red, just to say, oh, I'm still alive. So this is really just nothing, just to indicate the machine is working. That's all. Okay, so this is where we start the machine. The state initialized to idle, and we turn on the green LEDs. And let's look at the key, because that our first thing is when we are in idle state, when the key comes in, we go into the get money. And when the key comes in again, when we are in the get money state, it will stay in there until we get a timeout. But the key interrupt service routine, this is where the key interrupt service routine is. It's if the P1 IFG interrupt flag and button, it's if we got the interrupt on the key, we check the state. If the state is idle and we got a key, that means it's go from idle and we got a key, then we better go to that. The state is get money. And then because the first key has been entered, so we got a key count is 1. And we start a timer because the timer it's tick count go to 0. And the timer is already start, but the tick count keep counting. When the time keep counting, it's not a good idea that we keep it that number. So we just start fresh on the tick count. And then we blink the green to acknowledge the key has been hit. Okay, so if you are not clear about the tick count, let's look at we'll wait until we get to the timer interrupt service routine. You will be understanding a little more, will be a little more clear to you. And if we are already in the get money state, so this is where the state switch statements will do. If we get money state, okay, then key count increase. So this is where we get in this part of the loop of this diagram. After we got 1 keys and we continue to get a key, we just increase how many keys we get. And every time we get a key, we restart the timer. This is, in essence, it just says restart the timer and we acknowledge the key. Okay, yes, the switch statement, you can change it to if statements if you want to, but whenever there is a multiple state situations, I usually like to use a switch instead of the if statements. Hopefully it's a little more clear to you. Okay, so what's the other interrupt service routine? So this is the interrupt service routine for the timer. Look at this is a timer interrupt. Okay? And we are defining the interdigit tick. That means if it's 8, that means it's 4 seconds. If we do it within 4 seconds, then we consider it's a time out for the digits. Okay, so what is this interrupt service timer interrupt service doing with 2? Look at this transition diagram. Transition diagram is if we continue to get money, when we get a timeout, we're going to go to the pump. And look at the green parts here, blue parts here, tick count plus plus. And if all these are nothing, if the if statement is not, the whole if statement here, if this guy is not working, all this interrupt service routine is doing is to increase the tick count. So the tick count, we initialize it in the previous global. That's to right here. The tick count we initialize it is, in essence, is really just to count how many 500 milliseconds we have, how many clock tick we get. Each clock tick is 500 milliseconds. All right. So we got a timer, which is counting in the tick count. We'll keep counting from 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Keep counting up every time that the timer expired. The 500 millisecond timer expired. But because we restart the timer, every time we get a key hit. So inside this, if we have a long time, keep counting 0, 1, 2, 3, 4, 5, 6, 7, 8. And once you got to the 8, and we are in the get money state, so this is where this statement is. If state equal get money, and tick count is greater than 8, that means that that we got this particular timeout event. So when we got this particular timeout event, it's inside, it's the stage get money, and also the tick count is greater than 8. If tick count is less than 8, we continue to stay here because there could be another key hit. Okay. All right. And once we got the timeout, we go to the pump gas. That's why we put the state into pump gas. And then we start pumping the gas. And we pump the gas just using a simple for loop. Says, hey, we're going to blink. If we got $10, we blink 10 times. If we got $5, we blink 5 times. That's as simple as that. And once it's done, we transition the state to thank you state, and we blink the green and blink the red 3 times. So in this program, I think I only blink the green. It should blink green and red, okay? According to the requirements we had. And then once it's done, go back to idle. Now, you could easily argue that we don't really need to have this state. We don't need to have this state. All we have to do is just keep doing all this stuff. Yes, it works the same, but I'd really like to have the idea that, hey, if you put it into a different state, then later on, if you decide to change other things, then it's a little easier to modify your program. Also, it's a little easier to understand how the state transition is a meaningful representation of your requirements. Okay, that's where this program is, and it's a working program. You feel free to take it. So this is the main program. This is the ISR for the key, and this is the ISR for the timer. It's a study yet, and it will certainly help you. And then you can go enhance that, use your imagination to enhance it. Okay, so that's where we are, right?